In this tutorial, I will be showing how to have a placeable object that the player can place into the world. If you think of games like Minecraft or Fortnite, the player has the ability to place things into their own environment, and I'm going to be demonstrating a very simple way to prototype that kind of interaction. So what I already have set up in the scene is I have a ground plane for the player to stand on, and I have a first-person character controller from the Unity standard assets. I'm using the rigid body FPS character controller, and so if you want to pause the video right now and import standard assets so you can get the rigid body FPS controller, I'm using Unity 2019.2, and just as a warning, in Unity 2019, any version in 2019, the standard assets comes with a folder that is broken. It is inside of the editor folder, and it is called water, and you'll just want to delete that folder as soon as you import standard assets. It's not really needed for anything, and it causes a lot of problems. So I have my rigid body FPS character controller, and what I'm going to do is I'm going to add a script onto the main camera to detect what the main camera is looking at and to determine if you can place an object on top of it. So let's start by making a C# script. And I'm going to call this place object because that's what the script is going to do. I like my script names to be pretty descriptive of what the script does. It does not have a space in it. It's very important that script names do not have a space. And now I'm going to take that script and I'm going to attach it to my main camera. So I'm just going to drag it onto the main camera. I don't have a main camera in my scene outside of the rigid body character controller. Normally scenes come with a main camera, and I deleted it because I'm using the one that comes with the rigid body character controller. So I have my script attached to the main camera of the character controller. And what I'm going to do is I'm going to open up this script. And I'm going to give it a couple of public variables at the top. I want these to be public because I'm going to give them a reference to the objects in the scene or in the project folder, and I want to be able to just drag them in. So I'm going to make a public game object, and the first one is going to be a ghost object that is going to indicate to the player where they are placing the object. So this gives the user the ability to see what they are about to do. The second one is going to be the actual object that I'm placing. So this will be game object, and I'll call this one placed because this is the object that is going to be placed into the world. Then in my update function, what I want to do is I want to detect where the camera is looking, and we generally do that with a raycast. So what I'm going to do is I'm going to create a temporary variable called raycast. The variable type is raycast hit, and I'm going to name it hit. This is just kind of the standard format for doing a raycast, is to name it hit. The raycast hit is a variable that has data about what the raycast is colliding with. So it has information about the exact point that it hits, as well as what the object was that it hit. So now what I want to do is I want to check if a raycast coming out of the camera, and this is kind of long, so I'm gonna explain what each of these pieces does. So physics.raycast is going to cast a ray from a given point, and so the point I'm using is transform.position. That is the position of the object that this script is attached to, and you might remember I attached this script to the camera. So this is casting a ray from the camera, from the position of the camera, and it's casting it out into the world in a forward direction. So this transform direction, and then in parentheses vector3.forward. So this gets the forward direction from the point where I'm casting the ray. So this is going to be the direction the player is looking. out hit, this is a variable that is needed by the raycast function. This is what it's actually going to use to store the information. And this hit variable here, this is the hit variable that I just created up here. So you want those two names to match. So whatever you name your raycast hit variable, that's what you pass to this out. And then math.infinity, this tells it how far you want it to be able to go. And so if you wanted to limit how far the raycast could go, you could specify a smaller amount here. And so that brings us to the end of the if statement. And I seem to have gotten an extra parenthesis in here. So every now and then you might want to make sure that you have the right number of parentheses. Make sure that every open parenthesis has a corresponding close parenthesis. So this parenthesis here is closing the raycast, and then this last parenthesis is closing the if statement. And then I have my open curly bracket and close curly bracket. And then inside of this if statement, this is where I want to figure out what the player is looking at, and I want to show the ghost object. So the ghost object is going to be an object that's actually in the scene, and what I'm going to do is if my raycast hits something, I'm going to move the ghost object to that point. So I'm going to say ghost.transform.position equals hit. This is the variable that is collecting my raycast data. Hit.point. Point is the actual vector 3, the actual position where the hit happened, where the raycast hits an object. And this will detect hitting any object in the environment that has a collider. Right now, the only thing it's going to be colliding with is the ground. So I move the ghost to wherever that hit point is going to be. And I want to test that out before I go any farther. So I'm going to save my script. And I'm going to go back to Unity. And now I need to actually make my ghost object. So I'm going to make a 3D cube. This is going to be my ghost object. So I might want to scale it down a little bit. I'm going to do 0.5. And I want my ghost object to be a little bit transparent. It's sort of like a blueprint showing me where I'm going to place the object, but I don't want it to be fully opaque. So I'm going to make a new material, and I'm going to put it in my materials folder just to keep things organized. So I'm going to make a new material in here. And I'm going to name this material Ghost so I can remember which one it is. And I'm going to make it sort of a transparent green color. So to make something transparent, you use the alpha slider at the bottom, and then you pick the color. So you can see that it's sort of a transparent green. Here's a preview of what that color will look like up here. Now, if I just put this on the cube, it's actually going to be opaque right now. That's because the alpha on the color is not the only thing that determines the transparency of the object. The other thing is the render mode for the material. And opaque tells it doesn't matter what color you've chosen, it tells it that it needs to be fully opaque. So I'm going to change this to fade, which will allow it to use the alpha from the color that I've selected. And then when I'm happy with my ghost object, what I'm going to do is I'm going to drag it into the slot for ghost on my main camera on the place object script. And then I'll hit play to test it out. So an interesting thing happened there. I mentioned that the raycast will detect anything with a collider that it hits. And you might have noticed that the object came flying at me. That's because my raycast was actually hitting this ghost object because it has a collider. So I need to remove the collider from this ghost object. I don't want the raycast to hit the ghost object, and I also don't want the ghost object to be able to interact with the player. When it came flying at me, it actually pushed me backwards over the edge, and I definitely don't want the ghost object to be able to collide with things. So now I have my ghost object working correctly. So everywhere I look, anywhere I turn, the ghost object is updating its position to the point where my raycast hits. So the next thing I want to do is be able to actually place the object. So I'm going to make another cube. Actually, before I do that, one thing that I think will make this look a little bit nicer is if the object, instead of being sunk into the ground, if the cube is always sitting on top of the ground. And if you are using an actual model, chances are it has its pivot point at the base. But since I'm prototyping this just using cubes, I want to move the pivot point of my cube to the base. And the easiest way to do that is to just take my cube and duplicate it, Control D, and make the second cube a child of the first one. And then take that first cube object and remove the mesh renderer and the cube mesh filter. Now my child object is the only thing that has a mesh renderer, and my parent object can be used to store the actual transform information. So I'm going to take my child object and I'm going to move it up. And what I'm actually going to do so I can see what I'm doing, I'm going to take my parent cube object and I'm going to set the position to 0, 0, 0. So I can see where my cube is lining up. So the parent object, this is going to have the transform of where I'm placing things. So I've set that at 0, 0, 0 so I can see what I'm doing. And then the child object, I want to be sitting fully on top of the parent object. So I'm just going to move it up. And then if I click on the parent object, I can see that it now has the pivot point at the base of the cube. So that's a quick and simple way to give the object that you're placing a pivot at the base. So now if I hit play to test that, now everywhere I look, the cube is actually sitting fully on top of the ground. So the next thing I want to do is actually place the object. So inside this if physics.raycast, so if I've cast my ray, I've figured out where it's hitting, and now what I want to do is I want to have a check to see if the mouse button has been pressed down, and I'm going to use the click of the left mouse button to place the object. And so that will be input dot get mouse button down. So get mouse button down returns true on the frame that the user clicks. And it needs to know which mouse button, and 0 is the left mouse button, and I want to be the left mouse button clicking to be the thing that places the object. And then I have my open and close curly brackets. And all of this is going inside of the if raycast because I want to make sure that I'm only doing this if I'm actually colliding with something that I can place the object on. So if the user presses the left mouse button, I want to instantiate a copy of the placed version. The placed version is going to be a prefab object that I'm going to make in a moment, and I want to instantiate a copy of it. So I'm going to do instantiate, and the first thing we need in instantiate is the object that we're placing. So I'm going to use placed as the object I'm placing. And then I need a position and a rotation. And what I'm going to do is I'm going to say wherever is my ghost object, that's where I want to place my placed object. So I'm going to say ghost dot transform dot position and ghost dot transform dot rotation. So wherever my ghost object is, that's where I'm going to place my placed object. Go ahead and save those changes to the script, and then we're going to go back into Unity and we're actually going to make the prefab for our placed object. So I know that I want it to basically look like the ghost cube. The only real difference is I don't want it to have the transparent material, but I do want it to be the same size, and I also want it to have the pivot point at the base. So rather than going through all of those steps again, I'm going to Control D to duplicate, or Command D on a Mac, and this second object, I'm going to move it out of the way a little bit here. I'm going to rename this as Placed. So this will be my placed object, and the child, which has the material, I'm going to change the material here. So I'm going to navigate to where my materials folder. I'm going to create a new material. Actually, I think I'm just going to use the brown material that I'm using on the ground. So I'm going to basically make it like the user is changing their environment. So whatever this ground material it is, maybe it's dirt, so they're going to be placing dirt blocks or dirt cubes. So I'm going to drag this brown onto the mesh renderer under element 0 for the materials. So that's under the material category, and element 0 is where I'm placing the brown material. Then I'm going to make a new folder called resources. Generally, if you have objects or prefabs that you want to be able to instantiate in the scene, you generally want to keep them in your resources folder, so that anything in the resources folder will be included in a build of your game, even if it does not appear in a scene. So that's why it's helpful to keep anything you're going to be instantiating, generally you want to put in a resources folder. Then I'm going to delete the one from the scene because I don't actually want it to be in the scene from the beginning. And on my main camera, I'm going to drag this placed prefab from the resources folder onto the placed slot for my script. And so that, again, that was from the resources folder. I'm not dragging it in from the scene. My ghost cube I dragged in from the scene because I'm just actually moving this object around. But the placed object, I want to instantiate a copy. So I'm bringing that in from resources. I'm going to go ahead and save my scene, and then we'll test this out. So now I can place these cubes around in the environment. Now, one issue is I can't place cubes on top of other cubes, and this is actually because the placed object that I just made does not have a collider on it. So my raycast is not detecting that it is colliding with it. So I'm going to actually add a box collider to my placed object. If you double click on a prefab in its folder, it'll take you to the prefab edit screen. So I'm editing my prefab here. And I'm going to go to the child object, which actually has the mesh renderer and the cube mesh filter. And this is where I'm going to add a, I'm going to add a box collider. And you can see the green lines that it fully goes around the cube. That's because I placed it on the child object, which has the cube mesh filter. That's determining the size of the object, and making sure that it lines it up. If you were to put it on the parent object, you would probably have to adjust the size of the box collider so that it would match the outline. And it doesn't really matter if you place it on the child object or the parent object, as long as you make sure that the box collider goes all the way around the outside. And if you hit the back arrow here, it will save your changes to that prefab, and now we can test it out again. So now I can place blocks on top of each other. So this gives you an idea of how you can quickly prototype a system to allow the user to place objects in the world. If you wanted to have just a single object that the user is placing, say for example, if you have a crafting system where the user is crafting a house and you want them to be able to place their house in the world, you would want to have keep track of the number of objects the user can place, and each time they place something, subtract one to make sure that they eventually run out of those objects. Just to give a quick example of that, if I wanted, let's say I wanted the user to only be able to place 2 of these dirt blocks. Let's say they have 2 blocks in their inventory. So I would need to have a integer to keep track of how many they start with. I'm going to make this private because I'm only going to use it inside this script for right now, but this is something you might want to make public if you're going to change it in the scene. So I'm going to do private int total blocks equals, I'm actually going to do 3. I think it'll be easier to demo. So I'm going to do total blocks equals 3. Then in my if statement, if mouse down, where I instantiate the block, then I would do total blocks minus equals 1. So this subtracts 1 from this variable. So this variable will go down by 1 each time I place a block. So then in the update function, before I even do the raycast hit, what I'm going to do is I'm going to check if total blocks is greater than 0. So if the total blocks is greater than 0, and I'm going to take out this close parenthesis here. So what I'm going to do is I'm going to put the close parenthesis for this if statement at the end of all of this stuff that I'm doing. And you'll see it automatically indents for me so I can see what I have captured in this new if statement. So all of the code that I've written so far is going inside of this new if statement. I'm actually going to tab this whole thing over so that we can see it a little more clearly. So this open and close curly bracket, this is for the update function. Then I have this open and close curly bracket for my if total blocks is greater than 0. And now what I want to do is I want an else. So this will be if my total blocks has gone below 0, then what I want to do is I want to hide the ghost object. I want it to no longer be visible. So I'm going to do ghost.setActive false. I'm not going to delete it because depending on how I wanted this to work, maybe if I went and picked up more of these blocks somewhere, then I would have more in my inventory and I'd want to be able to turn it back on. So I'm going to save those changes, and go back to my scene and test it out. So now I've placed 3 blocks and my ghost object has disappeared. So I've used up all of the blocks in my inventory. And if you had something that was a unique item, you would just set total blocks to 1 in that case. Whoa, I fell. So that gives you a good idea of how to limit the number of objects the player can place into the world. I hope you found this tutorial helpful and that you can now use this method to create a simple placeable object interaction in your games. Thanks for watching, and I hope to see you in the next one.